All right, so here we have a polynomial. It is in factored form because that's going to make our lives easier. Do not multiply this out, okay? Do not multiply this out. That just complicates your life needlessly. Now, but our first question here is, hey, what's the degree? And we're going to say, well, you know, if I did multiply this out, what's the highest power of x I would get? So if I multiplied two of these out together, I would get an x squared, right? Plus some x plus a constant. And then when I add in, when I multiply that highest power from the FOILed, from the two terms, by an x minus 1, I'm going to get a highest power of x cubed. So my degree is going to be third degree. My leading term, there's no, all of these are just 1x, so it's going to be x cubed coming out of that, times 2, the one that's out front. So our end behavior, what do we know? It's odd, so they're going to go in opposite directions. It is not reflected over the x-axis, so we do expect our ends going this way. So we can write that out. We can say as x goes to negative infinity, y goes to negative infinity, and as x goes to positive infinity, y goes to positive infinity. Now, next up, where are zeros? So hopefully you remember that, you know, in factored form, if any one of those factors is equal to 0, the whole thing is equal to 0. So our zeros are going to happen when x minus 1 is equal to 0, when x plus 2 is equal to 0, and when x minus 3 is equal to 0. So our zeros are going to happen at 1, negative 2, and at 3. So 1, negative 2, and at 3. And that's the largest number of zeros that we could have, right? 1, negative 2. Because the largest number of x-intercepts or zeros that we could have would be the degree of the polynomial n, which is 3. And so we can sketch this thing pretty well. It's not going to be vertically stretched quite right, but we can get the idea of the graph because we know we've got to start down headed off towards infinity. So we're going to come up, go through this one, and then we just kind of are connecting the dots and make sure that we go through each x-intercept and that we end up going the correct direction with our end behavior. So let's pull up GeoGebra and see how close we were. All right, so we'll turn off that one. So this time we had y equals 2 times x minus 1, and make sure you put the multiply sign in there because sometimes it'll think that that's function notation. So I'm going to just be extra careful and put in multiply signs. I'm going to zoom to fit, see what we get. So does that match what we had said on our graph pretty well? You can see it down here, and yeah, pretty well. I mean, you can, we didn't get the scale right on the y, but I said that at the beginning because we don't really care about that at this point. So that's all that there is to these. You're going to have several homework problems like that. But let's do a second one. Now we'll put in a second video. Yeah. But we're going to do a second example similar to this.